Lovely. Thank you so much. Physical science. Hop on the board. Come see the monkey. Come on in. Okay. Hot dog. Outside. Now, we're going to take a look at one or two of these and give you more time. We're doing the single first. Okay. With single replacement, you should have this page ready with you too, the activity series, right? Okay. Single replacement. Okay. As write the formulas of the reactants on the left side of the arrow first. Okay. And on single replacement, I'm not worried about aqueous or whatever. So I see a lone element. It's an element. That means there's no charge. It's just lead. And I look up the symbol Pb. I'll just pull down the periodic table. So I'm going to put underneath here, the left side. Yeah. Pb plus zinc acetate. I got to figure that one out. So I use my ion chart side, not the periodic table. I say zinc, 2 plus, acetate, 2, negative. Right? If this was the other way around, I'd get this in, but it's not. Wouldn't this be like jacuzzi? Everybody loves a jacuzzi, right? Hot tub, but it isn't. Anyways, what's the formula for jacuzzi? Zinc acid. What's the formula? Like there's a 2 to 1 ratio of charges. So what do? You crisscross, right? Not a perfect match. I'm going to put it in here as Zn, 2 groups of acetate. And there we go. That's my step 1. Now, look at the activity series. See if the replacement can happen. Is lead, the lone element, higher than zinc? So we go through this. Lead. Oh, God. What does this mean? Is the lone element higher? No. So what do we do? What do we do? No reaction. But you have to look that up to know it. That's it. But I am still looking for if the element, or if the compound, zinc acetate, is written properly. There's no balancing. So the second one, let's see if this one happens. Calcium. It's the element calcium. It's not in a compound, so there's no charge. That's it. See it. Then hydrochloric acid. You don't have to look this one up because I wrote it up right beside it. I didn't talk too much about acid. Hydrochloric is hydrogen and chlorine ions together. HCl. Step 1's done. I'm trying to write though, and I think my board might have to start. Okay. Calcium. Is it higher on the activity series? You need that, I know. I'll always give it on its own. Calcium, oh yeah, it's the third one. Hydrogen. Way low, so definitely. This one happens. So now we have a little more work to do. I'm going to do a little bit of scratch work on the side. Calcium is going to go single thing, replaces the hydrogen, right? Chloride is going to stay as the ion. What happens is we've got to think this through. The calcium is in a compound. It's going to have a 2 plus charge. Chlorine as an ion is negative 1. You use the ion chart to look these things up, though. Right? These take time. So what's the compound that's going to be formed? Like calcium chloride, but I mean, what's the formula? There is H2. Okay, we'll get to that. This is going to be all by itself as an element. So H2. Why 2? Because there's 7 things. When they're elements, they come in. That was the first day we started review. 7 things. As groups of 2 diatomic elements. Hydrogen is one of the 7. How do you know which ones? There's 7 of them. Start at 7, make a 7. Nitrogen has N2, O2, F2, Cl2, Br2, I2, and then the 7th one is hydrogen. Okay. So that's by itself. Still haven't figured out what the formula is for calcium and chloride together. This goes. What is it? Ca, Cl, but does that cross? No, you need 2. You need 2 negative ones to match the positive. This is the formula. Okay. So step 2, we looked at the series, see that it can happen. Now we did the replacement. Complete the reaction. Now we have to balance it. Great, right? So, balance. Lord love it, Doc. Let's see. 1 calcium. Yep, 1 calcium. So far, so good. H. Gee willikers. I need 2 H's. 2 in front. Only balance with front numbers, right? Now, 2 H's. Now I've got 2 Cl's on the side, on the left side, right? And we happen to have 2 Cl's on the right side. It's balanced. Okay, those are the first 2. Go with it. Oh, keep going. Do that. She shouldn't have said that.
Good morning.
Good morning. Welcome to, say it like, in case you've just joined us, this is physical science in progress. Now, we've got to do copper and water. So we hopefully did this. See you. Now, I suggested, you can write it as H2O, but I like to think of water as H and OH together. That's why I put this hint. It's really a hydrogen ion combined with, think of it this way, hydrogen ion combined with a hydroxide. So I'm going to put it as HOH. Maybe I'll even just color it a little differently. HOH. Just so you see why. Because I'm trying to find out if this switches places. Copper, right? Oh, got the wrong thing. Like you did. So does the copper go into that? That's what I really want. Well, we have to use the chart. Is copper higher than hydrogen? Son of a bitch. Look at that. Copper is 1 lower. Nothing happens. No action. That means no balancing. But I still need formula on the left. Right? Now, iron as an element, it's just as here. No charge. Aluminum oxide. I look up aluminum. You've got to use the iron chart. Unless you have these memorized, and I only do because I've done this a lot. But if I was a parent who didn't teach chemistry, I wouldn't have a clue. I'd have to use geometry. Anyways, what's the point of aluminum oxide? Because you don't have to actually write these out, but this is what you look up on. Yeah. L plus 3? No. Crisscross. I need 2 groups of 3. 3 groups of O. L2, O3. Is the iron higher than the aluminum? Activities. Aluminum. I'll be darned. Iron, aluminum. Not going to happen, right? Not going to happen. It's like something else. Up. Okay, something's got to happen. Magnesium, nitric acid. Magnesium, the symbol for magnesium as an element. Nitric acid, I gave H and then okay, that's as a compound. We know that NO3, well, you put that. Anyways, so I'll just stop. Will hydrogen and magnesium switch places? Right? Hydrogen, magnesium. Look it up. And magnesium is the lower, right? It's higher. It's going to happen. Hydrogen will be the lone element. This is group 2. We did that previously. One of the 7 diatomic. Now, I got to figure out what magnesium charge. So I look it up. Nitrate's charge. I look it up. Hey, that's a 2-to-1 ratio as well, or 1-to-2. We have 2 plus 2 groups of -1. That's why the formula. MgNO3. But if I have 2 groups of NO3 because it's a polyatomic, I need to put that. There we go. Now I need to tell. 1 Mg left, 1 Mg right. Okay, good. 1 H from the HNO3, 2 groups of H2 left. I need to double this. Only balance with prime numbers. Now I've got 2 H's. Awesome. 2 H's. I've also got 2 groups of NO3. Now look at this. I've got 2 groups of NO3. That one number 2 does everything. Last. Lead, Pb. Iron to nitrate. Well, I gotta look this up. Maybe I don't, but here's what I think. Because it tells me that it's iron 2 plus 2. Nitrate, NO3. That formula, it's a 1-to-2 ratio again, right? Fe bracket NO is lead higher on the list. It ain't, right? Lead lower on the list. No reaction. Now, this one didn't happen, but some people might be wondering, what would happen if I did switch that around and I look up lead then and see what it is in the column? Go with the one that's listed on the top, by the way, because lead has 2 and 4 listed, right? Go with the one, and you notice that lead 2 is listed above lead 4 on the iron chart. If it didn't change, go with the one that's listed first, okay? But that's not the case. So, this practice, no. Now, you have to practice double replacement. Switch over to that. Now, the first one, have down. I'm going to go through the second one. I think I just started on this, didn't I? Right, the formulas of the reactants on the left side of the arrow include AQ in the brackets. I mentioned this the other day. I'm not trying to fool you. The left side, the reactants, are guaranteed to be AQ on these. So, I just need to figure out what silver and nitrate are. But this time I'm just going to say it. But you got to look on the iron chart. You see silver, Ag plus. Nitrate, NO3 minus 1. That's a plus 1, minus 1. They're a perfect match. So I can just write them down beside each other, no brackets required. Ag and NO3. And I know, without looking it up, that it's Ag. So, sodium chloride, you're probably familiar with that. There's Na plus, Cl minus, 1 to 1. Familiar with it because that's table. Now, right? Possible products on the right-hand side. that means, I'll do this in green here, like I was doing. Ag plus NO3. This is what I had thought about when I came up with this one. Na plus, yep, Cl minus. Double replacement means two things switching places within two different compounds. So essentially we're saying, what if this sodium, the silver, swap apart? Well, we would get still 1 to 1, so it'd be sodium nitrate, just written as it is. We'll look things up after. And NO3, since there's only one group of NO3, no bracket required. We'll look that up. Plus HECl. I wrote step 3 and 4. Maybe I should reverse the order. Here's the solubility chart to predict what it is solid and what's aqueous. So, please remember this. Sodium nitrate, silver chloride. What? Sodium nitrate. Any nitrate. Solid. By the way, any sodium compound is solid. That'll be aqueous. The chloride, it's silver. Solid. Put that in. Aqueous. So this reaction happens. I'm going to balance it. But I look through it left to right. One silver, one silver. One NO3, one NO3. It's balanced. All one. So you don't worry. Cool with that? You got 2 more to do. I know you can do them. So you're going to do. This is to be done. Please. Go. Yep. Just going to record on the video what's happening. Left. Just sort of high. Stop talking about it. Work. Work. So, switch on. ions. The formulas are red. Come up. Barium carbonate. Barium is not listed in the carbonate rule. It's one of the others. It's low solubility. Potassium chloride. Okay, two CLs now. That's two CLs, one there. Everything else down.